Hello everyone, I am Bradley Sward, and this is my Day 25, Part 1 solution for the Advent of Code 2024. The problem is called Code Chronicle. As always here, I am solving the problem in Python. So the problem is as such: you have a bunch of locks and you have a bunch of keys. We all know locks and we all know keys. Maybe we don't know all of them as in physical forms like I used to, and we all in the analog form as we're growing up, and now we're into the digital world where everything is, passwords and all sorts of stuff rather than just physical keys and locks. But looking at this, basically, you're getting things 8 lines at a time, and you're just trying to figure out how many, basically for each column of these 5 columns for each of these rows, you're like, well, how many octothorpes, how many, hashtags, how many pound signs are there? And you're like, well, in this case, coming down to here, you go, well, in this case, there's 0, and then there's 5, and then there's 3, and then there's 4, and then there's 3, and this is a lock because it works down. So the lock starts from the top and works its way down. This one doesn't count, so it's just, who cares about that? It's always there. And I guess we could have worked it into the problem, but yeah, whatever. It doesn't matter. But for this one here, it's the other way around. You're like, well, there's 5, there's 0, there's 2, there's 1, there's 3, but this one's a key because this whole row of octothorpes is at the bottom as opposed to being at the top. And so the first step was basically to convert all of these graphs into a numeric code, and then from there you just basically are just saying, for every lock and every key, just try each combination and how many of them can work. And you're not trying to find exact matches for keys, you're just trying to find something that might fit. And so, like in this case, like this, all the columns, basically you're just looking at, you're adding up both columns of each of them, and in each column, or when you add it, when you add up each individual number and get the values you're looking for, you just have to make sure you have something that isn't greater than 5, because then the key and the lock can't match no matter what. So like the part 2 for this problem would be, who knows what. It would probably, but that's just not what we're doing here, because when I get the part 2 of day 24, I'm going to be done. So anyway, so the answer is 3395. This is how I do it in Python. Get me all the lines. Let's go 8 lines at a time. Here is the number of heights, and just basically just go through and just get me all the octothorpes, add it up, and then the tricky part, if it's even tricky, was just to say if the first line of this thing is all octothorpes, I love that word, octothorpe, obviously, then put it into the locks list. Otherwise, it's not a lock and it has to be a key. And then you just go through and you just add up. I love this else when it comes to for state. I wish C++ and all other languages would do this too, because it's really cool, because it's like, okay, well, if at any point, if I add up the numbers and I get something greater than 5, then no, it's not going to work for me. So I just go through for every lock and every key. How do I do what I do? My data set is, there's 500 locks and keys combined. You do the math, you do the work, you get yourself to a position where you get the answer of 3,300 and whatever it was, 3,385? 3,395. And that is the solution to day 25, part 1. And one day soon, I'm going to be celebrating day 25 part 2, because what you do here is basically, when I get the 49th star, I'll probably be able to click or type something in. I don't know what. It's gonna be fun to figure out what to do, and I'm gonna win. I'm gonna have all 50 stars. So anyway, thanks for watching as always. Hope to see you very soon in the next videos. Take care, everyone. See you then.